Section 1.2. The Cloud and the Cloud Computing Model. Before focusing on the main characters, the cloud-native applications, I'd like to set the scene by describing the context in which cloud-native applications run. The cloud, Figure 1.2. In this section, I'll define the cloud and its main characteristics. After all, if cloud-native applications are designed to work well in a cloud environment, we should know what kind of environment that is.
Figure 1.2. The cloud is an IT infrastructure characterized by different computing models and offered as a service by providers according to the degree of control consumers need.
The cloud is an IT infrastructure that supports the delivery of computing resources to consumers according to the cloud computing model. The National Institute of Standards and Technology, NIST, defines cloud computing as follows. Cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. For example, networks, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. Just like you get electricity from a provider rather than generating it on your own, with the cloud you can get computing resources, such as servers, storage, and networks, as a commodity. The cloud provider manages the underlying cloud infrastructure, so the consumer doesn't need to worry about physical resources like machines or networks. Companies moving to the cloud can get all the computing resources they need via a network, usually the internet, through a set of APIs that allows them to provision and scale resources as they need on an on-demand, self-service basis. Elasticity is one of the main characteristics of this model. Computing resources can be provisioned and released dynamically depending on the demand. Elasticity is the degree to which a system is able to adapt to workload changes by provisioning and deprovisioning resources in an autonomic manner, such that at each point in time the available resources match the current demand as closely as possible. Traditional IT infrastructures weren't able to provide elasticity. Companies had to calculate the maximum computing capabilities needed and set up an infrastructure that would support that, even if most of it was only required sometimes. With the cloud computing model, the usage of computing resources is monitored, and consumers only pay for what they actually use. There is no strict requirement about where the cloud infrastructure should be or who should manage it. There are several deployment models for delivering cloud services. The main ones are private cloud, public cloud, and hybrid cloud. Private cloud. Cloud infrastructure provisioned to be used by a single organization. It can be managed by the organization itself or by a third party, and it can be hosted on premises or externally. A private cloud is usually the preferred option for organizations dealing with sensitive data or highly critical systems. It is also a common choice for having complete control over the infrastructure's compliance with specific laws and requirements like the General Data Protection Regulation, GDPR, or the California Consumer Privacy Act, CCPA. For example, banks and healthcare providers are likely to set up their own cloud infrastructure. Public cloud. Cloud infrastructure provisioned for public use. It is usually owned and managed by an organization, the cloud provider, and is hosted on the provider's premises. Examples of public cloud service providers are Amazon Web Services, AWS, Microsoft Azure, Google Cloud, Alibaba Cloud, and DigitalOcean. Hybrid cloud. Composition of two or more distinct cloud infrastructures belonging to any of the previous types, bound together and offering services as if they were one single environment. Figure 1.3 describes the 5 leading cloud computing service models, what is provided by the platform in each model, and which abstractions are provided to the consumer. For example, with the Infrastructure as a Service, IaaS model, the platform provides and manages computing, storage, and networking resources, whereas the consumer provisions and manages virtual machines. The decision about which service model to choose should be driven by the degree of control the consumer needs over the infrastructure and which type of computing resources they need to manage.
Figure 1.3. The cloud computing service models differ by the level of abstraction they provide and who is responsible for managing which levels, the platform or the consumer.
Section 1.2.1, Infrastructure as a Service, IaaS. In the Infrastructure as a Service, IaaS model, consumers can directly control and provision resources like servers, storage, and networks. For example, they can provision virtual machines and install software like operating systems and libraries. Even though this model has been used for a while, it was in 2006 that Amazon made it popular and widely accessible with Amazon Web Services, AWS. Examples of IaaS offerings are AWS Elastic Compute Cloud, EC2, Azure Virtual Machines, Google Compute Engine, Alibaba Virtual Machines, and DigitalOcean Droplets. Section 1.2.2, Container as a Service, CaaS. Using the Container as a Service, CaaS model, consumers cannot control primitive virtualization resources. Instead, they provision and manage containers. The cloud provider takes care of provisioning the underlying resources that fulfill the needs of those containers, such as by starting new virtual machines and configuring networks to make them accessible through the Internet. Docker Swarm, Apache Mesos, and Kubernetes are examples of tools used to build container platforms. All major cloud providers offer a managed Kubernetes service, which has become the de facto technology for CaaS offerings. Amazon Elastic Kubernetes Service, EKS, Azure Kubernetes Service, AKS, Google Kubernetes Engine, GKE, Alibaba Container Service for Kubernetes, ACK, and DigitalOcean Kubernetes. Section 1.2.3, Platform as a Service, PaaS. In the Platform as a Service, PaaS model, the platform provides infrastructure, tools, and APIs that developers can use to build and deploy applications. For example, as a developer, you can build a Java application, package it as a Java archive, jar, file, and then deploy it to a platform working according to the PaaS model. The platform provides the Java runtime and other required middleware, and it can also offer extra services like databases or messaging systems. Examples of PaaS offerings are Cloud Foundry, Heroku, AWS Elastic Beanstalk, Azure App Service, Google App Engine, Alibaba Web App Service, and DigitalOcean App Platform. In the past few years, vendors have been converging on Kubernetes for building a new PaaS experience for developers and operators. Examples of this new generation of services are VMware Tanzu Application Platform and Red Hat OpenShift. Section 1.2.4, Function as a Service, FaaS. The Function as a Service, FaaS model relies on serverless computing to let consumers focus on implementing the business logic of their applications, often in the form of functions, whereas the platform takes care of providing servers and the rest of the infrastructure. Serverless applications are triggered by events, such as HTTP requests or messages. For example, you might code a function that analyzes a data set whenever available from a message queue and computes results according to some algorithms. Examples of commercial FaaS offerings are Amazon AWS Lambda, Microsoft Azure Functions, Google Cloud Functions, and Alibaba Functions Compute. Examples of open-source FaaS offerings are Native and Apache OpenWhisk. Section 1.2.5, Software as a Service, SaaS. The service with the highest abstraction is Software as a Service, SaaS. In this model, consumers access applications as users, while the cloud provider manages the whole stack of software and infrastructure. Many companies build their applications, use a CaaS or PaaS model to run them, and then sell their usage to the end customers as SaaS. The consumers of SaaS applications typically use thin clients like web browsers or mobile devices to access them. Examples of applications available as SaaS are ProtonMail, GitHub, Plausible Analytics, and Microsoft Office 365. Platform versus PaaS. Platform is a term that might generate some confusion in a cloud-native discussion, so let's clarify. In general, a platform is an operating environment you use to run and manage your applications. Google Kubernetes Engine, GKE, is a platform that offers cloud services according to the CaaS model. Microsoft Azure Functions is a platform that provides cloud services following the FaaS model. At a lower level, if you deploy your applications directly on an Ubuntu machine, that will be your platform. In the rest of the book, whenever I use the term platform, I mean the broader concept just explained, unless specified otherwise.